Assalamualaikum and good day. In this video, we are going to discuss why we need to obtain the principal stresses by treating the problem as an eigenvalue problem. Put it differently, what is lacking with the equations from Mohr circle that we have? So these are the questions we want to answer. In our previous video, or if you haven't watched it, that's okay, because this is something that you have learned during your first or second year. In our previous video, we have shown that for 2D problem, the principal normal stresses can be obtained from these two equations, which in turn derive from Mohr circle. Now, look carefully at the equations. What can you notice? Okay, look at the square roots. The square root. Look at the square root. Look at the 4 multiplier we have here. And look at the positive and the negative sign. Do all this remind you of something? They should remind you to the solutions of quadratic equation, shouldn't they? They can generally be expressed as, which I'm sure you are very familiar with these equations. Okay? In fact, we can see the similarity if we take, between the general expression of quadratic roots or quadratic equations and the general expression or the equation for the principal stresses, we can see them. We can see that they are similar if we take A equals to 1, B equals to sigma x plus sigma y, and then C equals to sigma x, sigma y, and then tau xy. Okay, but don't worry about this. Yeah, this is not what I want to discuss. Yeah, I just want you to notice. Yeah, I want you to notice that means this solution must come from a quadratic polynomial. Yeah, it must come from this. Okay, polynomial in sigma. Okay, now this is a very important observation. Okay, you need to hold to this. All right. So um, so we can expect that. Yeah, we can expect that since for 2D it will lead to bear with me. Yeah, since 2D will lead to quadratic equations. And then later will lead to two roots, hence two principal stresses. So we should then expect if we have a 3D stress state, it should lead to cubic polynomial, okay, which we can write it as this. And we should know that if we have a cubic polynomial, we should have 3 roots, okay, and which also means that we should have 3 principal normal stresses, okay. Now let me ask you, do you know any solutions of Mohr circle for 3D? There is actually, but it is itself derived from eigenvalue argument. So for the purpose of our discussion, we can say that for 3D, Mohr circle is no longer convenient. Thus, we need to have a different approach. And that approach is by treating the determination of the principal stresses as an eigenvalue problems. Indeed, this is an approach that suits computer programming and software development because, as you're gonna see in the later videos, they will be in the form of metric analysis. Okay, so that's it. This is going to be a short video. I just want to put forward to you why we need to treat, hence learn how to get the principal normal stresses as eigenvalues. Before we end this video, as usual, let's talk quickly about what is the importance to know all this. Yes? I mean for you engineers and researchers. Now, this is one of the importance, yeah? Now, as you can see in this figure, we have 2 figures. Now, the first figure is the modeling of steel section employing 2D elements. Yeah, for the web, it uses plane stress, and for the plates, for the flange, it uses either plate or shell element. But still, the elements are 2D, and for this 2D, then we can use the Mohr circle equations for the principal stresses. But on the second figure, it shows the modeling of RC beam employing 3D solid element. In ANSYS software, the determination of the principal stresses are all based on eigenvalue problems, because that is the way to proceed when it comes to software and computer programming. And this is another evidence, yeah? So this is, I mean, I took this from ANSYS manual, and it described about principal stresses as an eigenvalue problem. Now, by looking at this, then we have the evidence that in ANSYS, determination of the principal stresses is based on eigenvalue problem. So, to appropriately use ANSYS, of course, we need to read the manual. But as you can see here, there's a lot of fundamentals knowledge we need to know before we can read the manual. So I hope the importance now obvious. Okay, that's all for this video. In the next video, we will detail further the eigenvalue problems, the calculations, the procedure, yeah, for the principal stresses as well as their directions. Until then, Assalamualaikum and take care.